Hi, my little friends. Those of you who have been in my STEM class before know that I like to end the year with an ice cream party. This year is no different. So it's going to be a little bit different than we have in the past, but there's still going to be ice cream. So we're going to need your parents to get on board with this idea. So, Mom and Dad, we can make this a very fun experience, and everybody gets to have ice cream. So, if you could please get your ice cream out, and we will get started. So I have my three victims, children, here to help me with our experiment. Why does my ice cream melt? Smart answers to STEM questions. Ever eat ice cream soup? If not, here's how to make it. Put a scoop of ice cream in a dish, leave it alone, wait. This is the slow but sure recipe for making ice cream soup. Okay, so the first thing that we are going to do is make ice cream soup. While you wait, look at the scoop of ice cream. Does it have a shape? Is it the same shape as the dish, or does it have its own shape? If it is a scoop of ice cream, its shape is a hemisphere, which means half a ball. Does the ice cream take up space? Things that have their own shape and take up space are called solids. Frozen ice cream is a solid. Do you see any other solids? How about the dish? How about the table? How about a spoon? Tired of waiting? Put a spoonful of ice cream in your mouth. Wait before you swallow. Feel what's happening to the ice cream in your mouth. Let the ice cream melt completely in your mouth before you swallow it. It's a short wait. Got that? Okay, now you can swallow. Your mouth is the quickest and best way to make ice cream soup. Put a spoonful of ice cream in your mouth. Wait before you swallow. Feel what's happening to the ice cream in your mouth. Let it melt all the way. Is it all the way melted? Okay, now you can swallow. Because your mouth is the fastest way to make the ice cream melt. What makes ice cream melt? Here are some hints. Touch the ice cream. How does it feel? Dry your finger and hold it in the air. Is the air warmer or colder than the ice cream? Put your finger in your mouth. Is it warmer or colder than the air? Good. Put your finger in your mouth. Is it warmer or colder than the air?
Tastes like dirt.
Put your finger in your mouth. Is it warmer or colder than the air?
It's warmer.
Heat makes ice cream melt. Heat is a kind of energy. There is heat in the air and heat in your mouth. Try to speed up making ice cream soup in the dish. Now, Katie, it is nearly 90 degrees outside. Do you think that if we put your ice cream outside, it would melt faster or slower than inside the house?
Faster.
See what happens if you cut it up in small pieces with your spoon. When you break up the ice cream, there is more surface touching the heat in the air. Next, try stirring the pieces around. Stirring is motion energy that changes to heat. Here's how you can prove that. Rub your hands together quickly. See how they get warmer? Heat energy and motion energy both melt ice cream. When you have no more solid lumps, you've made ice cream soup. Now we're going to see what happens if you cut it up into small pieces with your spoon. And stir those pieces around. Speed up that soup.
Can't.
Okay, Danny, now rub your hands together quickly. Do they feel warmer?
Yes.
Before you slurp your ice cream soup, pour a small amount into a paper cup. It is now a liquid, so you can pour it. Has it lost its shape? All liquids, including ice cream soup, have the shape of the container and is flat where it meets the air. I think somebody is cheating.
It's not my fault.
Put the cup of ice cream soup back in the freezer. Think you'll want to eat it after it's frozen again? You'll have to wait to find out. It takes a few hours to freeze completely, maybe all day. Ice cream is made of cream, milk, sugar, and flavoring, like vanilla or chocolate or strawberry. The part of ice cream that freezes is already part of the cream and the milk. Can you guess what it is? It's water. Know what you call frozen water? Ice. It's hard to see the ice in ice cream, so do what scientists do. They take apart their subject. Look at ice separately from ice cream. Get an ice cube from the freezer, touch it. How does it feel? If you put it in a dish, will it melt? You bet. Scientists imagine how water changes from ice to liquid water. First, imagine that water is made up of tiny particles that are so small that no one has ever seen them. They are called molecules. Water molecules are made of even smaller particles that stick together, called atoms. There are 3 atoms in a water molecule. 2 are hydrogen and 1 is oxygen. We imagine that they are arranged like ice with 2 ears, almost like Mickey Mouse. When water is frozen, the molecules are held together in a regular shape called a crystal. Snowflakes are tiny crystals. Look in your freezer. See if you can find tiny ice crystals. Those form from water in the air in the freezer. Ice cubes are big crystals. In any ice crystal, water molecules can't move freely. They are in a regular shape that doesn't change. The molecules can't move around, but they can shake in place. Heat makes them shake faster and faster until they become loose and can roll around each other. That's what happens when they melt. In liquid water, the molecules are moving fast enough to roll over each other. They can stick together for a moment, but then break apart easily. The space in the ice crystal is what makes ice float in real life. Do you like to eat solid ice cream better than soup? Most people do. So here's the problem. Is there a way to keep your ice cream from melting too quickly? That's the kind of question that is solved by scientists called engineers. What can you put in it? What can you put it in so that melting slows down? Go on a container hunt in your kitchen. Find small containers with bases that are about the same size. They should all be made of different materials. A dish, a china cup, a mug that is used to keep coffee hot in a car, a plastic cup made of styrofoam. Line them up on the counter. Working quickly, put a tablespoon of ice cream straight from the freezer into each container. The melting race is on. See how fast they melt. When the last one has melted, taste each ice cream soup. Which is the warmest? Is one still cold? The containers that keep things cold the longest are the coffee mug and the plastic styrofoam. That's because heat doesn't travel well through the mug or the styrofoam. Materials that keep heat from moving where you don't want it are called insulators. So a mug that is designed to keep hot things hot can also keep cold things cold. You can experiment with other materials like foil or cardboard cups or ice cream cones. Do they slow down the melting, or do you just have to eat fast? Okay, now Katie has her ice cream on one side and a little bowl with ice cubes on the other. Now Katie, are you ready to do an experiment where we see which melts faster?
No.
The ice cream or the ice cubes?
No.
Why not? What's going to happen?
I want to eat my ice cream.
See if the ice cream soup you put back in the freezer is frozen. You may have to wait until tomorrow to do this. If it is, try to stick a spoon in it. Try and taste it. Does it feel like there's sand in it? If so, the water has frozen into bigger crystals that you can feel with your tongue. That's because some of the water in the ice cream soup formed bigger crystals when you refroze them. It's not smooth like fresh ice cream. Ice cream makers beat the ice cream as it freezes to keep the ice crystals so small that you can't feel them. I hope that you've enjoyed this year's STEM lessons as much as I have, and I hope that I get to see you again in person really soon.